First of all, welcome to everyone to this 13th Tech Talk, ALASCA Tech Talk. In case any of you are joining for the first time, I would just have a very brief introduction of the format and what you can expect. My name is Maria. I'm with Clouditor Technologies, and I usually moderate these tech talks. So very happy to be here today. Just a warning that the session is going to be recorded. We will upload the video to YouTube afterwards, so you should already have seen a notice when you joined the Zoom call, but just another warning on that. So we have a very brief agenda as always. First, we have a tech talk followed by a discussion. This will take around maybe 20 to 30 minutes with a tech talk, and then we have 10 or 15 minutes for a discussion. And then we have always a section on news and events. We have a couple of very interesting news and events to share with you today. So it's also open to everyone. If you have any other news or events that you want to share, that there's also a possibility to do that afterwards. So today we have a very interesting tech talk. We are very happy to have Christian Banse as a guest with us today. He's quite an expert in security, and as you see here, he has studied a Master of Science in Information Systems, so with a focus on IT security, and he joined the Fraunhofer Institute for Applied and Integrated Security in 2011, and he heads one of the departments there right now, Service and Application Security. So a very interesting profile to talk about security in the cloud, I guess, and he's also an author of numerous publications on in the field of cloud security and particularly in cloud certification. So today, Christian will present Clouditor, which is a tool developed by Fraunhofer. It's a tool to assure the security of cloud services. So I will not take any more time. Christian, whenever you're ready, I'll stop my sharing and then you can start with yours.
Okay, thanks. So let me just quickly go to here and okay, let's begin. Okay, so thank you very much for the introduction. So maybe before we start with Clouditor, just some brief words about myself, and also because this is all in the scope of open source, so maybe just two words about my connections to open source. So in my work life, as Maria said, I'm the head of the department here at Fraunhofer AISEC, and within the department, we developed multiple open source projects. I'm not involved in all of them, but just to give you an idea and the broad spectrum here, we are developing software, for example, for static code analysis, mostly Java, C++, Go, Python. We also have the Clouditor tool that I'm presenting today, but we also have, for example, implementations of cryptographic libraries, for example, attribute-based encryption with librabe, which is a Rust implementation and so on. So quite a broad spectrum, but a lot of open source projects that mainly come out of research projects and then evolve into maybe bigger projects. But I'm also a big supporter of open source in my private life, so mainly GitHub at Oxisto. If you want to look me up, main technologies here that I use are Go, TypeScript, Svelte, and you will find a lot of them as well in Clouditor. And I'm also the co-maintainer of Go, which is basically, I think, most used Go library for parsing and validation JSON Web Token. So it's as sort of a relationship also to my work life. And a lot of projects that will probably never be finished, from security, finance, stuff like that. So the usual GitHub profile where you start something and then probably never finish. But so if you want to help me in my projects, please look me up and try to contribute. But yeah, back to Clouditor. So what was our motivation and challenge we wanted to address? So as you all know, we are living in a world where there's basically every day a new standard in terms of security. So we have really an increased number of security certifications, regulations. So just to name a few, GDPR, now we have the Cyber Resilience Act, which is in everybody's mind at the moment, and how to react that. We have the EU Cybersecurity Act, which is a little bit older, some ISO standards, the BSIC5. So we have basically a lot of standards that at the end one might need to fulfill because of legal reasons, or might want to fulfill because it's a demonstration of security or compliance to the customers. So there are different reasons behind that in order to fulfill such a standard. But it puts an increased pressure on companies to fulfill these requirements, and at the same time we have even shorter in short, the development cycles, because you need to push your product to the market, basically. But what you don't need to forget is that you need to provide sort of evidence that you need to fulfill these standards. It's a little bit different per standard, how, let's say, sophisticated this evidence is, but in the end, you need something to prove that you're fulfilling these requirements of a standard in terms that you can hand it to an auditor, for example. And on the other hand, of course, as I said, we have shorter development life cycles and also increased complexity in cloud services. I don't need to talk about this, I think, specifically, and everybody knows that. And now even with generative AI and stuff like that, everyone is just generating code and code and code and code. So it's getting worse a little bit. So I think the only way out of that is at the moment that we need to do automation here. So we can check automatically if certain things are fulfilled or not. And also there is a trend in the standards that this is going to be continuous in a way, whatever that means. So continuous needs automation, but it's not quite sure yet how continuously you really want to do that. Is it every minute? Is it every second? It also depends a little bit on the requirement. But this is basically was the setting where we said, okay, we had a research project, it was called Medina on the right side, and we want to say, okay, we want to provide a tool for companies and developers how to deal with sort of this environment. And out of that came the open source tool Clouditor, which is, as we said, it's a tool to support continuous monitoring of these cloud services. Technology stack is Go, Rego, we'll come back to that a little bit, and SvelteKit for the UI. It basically works that in a way that you have a discovery of resources, and we have basically resource discoverers for the well-established cloud providers, so AWS, Azure, but also open source projects like Kubernetes, OpenStack. And then we have a built-in rule engine that assesses the security configuration of the resources that we discovered and basically says, okay, this is okay, and this is compliant to a certain standard. And we can address security controls of requirements of different standards. So not all of them are in the open source repo. So this is a little bit also, let's say, the strategy of Fraunhofer at the moment to have this open core model. So a lot of it is in the open source repository, but there are also individual offerings available. And so not everything is in the open source repo. And it's also part of the project a little bit. And we have ongoing European projects like the Emerald and the Cobalt project where we develop this even further. Now, in designing that, we basically set ourselves 3 major design goals. So we want to have something that is scalable because we need to fetch probably thousands or hundreds of thousands of evidences if you have a large cloud service that you want to assert. Then all components should basically be able to launch multiple times, so you don't have any bottlenecks. So you just can spin up, I don't know, 5 of these components if you want to have the load balancing for that. So we need to assert that in the architecture. We want to be vendor independent in a way that we say, okay, we want to support different cloud providers, and we also want to build security rules and assessment rules that work on multiple cloud environments and not just specific to one. I'll come back to that in a minute. And we want to be ready for multiple certification schemes. So as I said in the beginning, there are just a lot of them. The content is sometimes similar, so it makes sense to not do things twice. So if you have a certain security property that you demonstrated, you can probably reuse that in different certifications or different standards. And so we want to gather evidences with a high level of reusability to just say, okay, we can demonstrate compliance to multiple certification schemes, for example. So how does it work? So I will go to a little bit how we try to address these design goals in the individual things. So first of all, in the API design and components, so this is the main thing where basically we want to provide the scalability aspect. And okay, what do you do? Well, one of the, let's say, most obvious thing is you want to split up your big component into smaller ones. So you're ending up with sort of a service or microservice architecture. Sorry for the weird UML diagram on the right. It's a little bit full of errors and so on because it's auto-generated and we didn't really have time to put more style and colors into it, but it's basically generated out of the real thing. It's also a little bit based on the V1 version of Clouditor. We are working currently in V2 where we also address some of the architecture aspects, but it should just give you an idea of the different components. Basically, there are 4 main components. There is the discovery. This then interacts with the different cloud providers and generates what we call an evidence. And there are basically different flavors of this discovery for different cloud technologies. Then the next step is an assessment because we want to do an assessment of that particular evidence using a metric. To give you an example, for a metric, it could be something like the TLS version used, or did you enable disk encryption, or also the strength of this encryption. All of these things that are basically properties that we call metrics in a way. So we want to assess the evidence. Evidence could be, for example, the interaction of an API and to fetch, for example, a virtual machine property. And then we want to assess it basically on this evidence, a certain metric. And we do this using a metric implementation in Rego. I'll come to that in a minute. Then this produces an assessment result. And these assessment results are then stored in the central place, which is called orchestrator. Even though the orchestrator is a central component, you can still also scale that in a way because there is no state in these components. So you can also have basically 10 orchestrators. In the end, they should talk to the same database. So that database could be a little bit of a bottleneck. So if you want to scale the database, of course, there is a lot of things you can do there with like Postgre clusters and so on. So I won't go into detail with that. But basically also the orchestrator is a central component, but you can still scale it. And then in the end, we have an evaluation component, which basically aggregates these multiple assessment results into an evaluation result specifically for a catalog, because in the end, you need to do some kind of thing that is specific for one certification that says, okay, you failed this particular certification, like the PSIC5, using the assessment results we gathered before. And how does that all work behind the scenes? So we are very focused on APIs, and we are sort of protobuf first, which is a little bit unusual for some people because usually people say, REST APIs, GraphQL, whatever. But we are very focused on protobuf. As sort of a companion to protobuf, we are using gRPC between the service to service communication, which is quite nice because you can do things like streaming in gRPC. You can sort of emulate event bus behavior in gRPC. You can react to things. So gRPC is quite nice to deal with all these different things that are basically happening between our components. We do offer a REST API because some people want a REST API. There's a nice little project called gRPC Gateway, which basically you can annotate your gRPC files with some annotations, and then they will also turn into a REST API that is auto-generated. So even that works, but internally, basically, all of our tools and our communication is based on gRPC. And you can see that on the right. So we're basically using gRPC as a communication protocol, but also as an interface definition language, as protobuf was also originally designed. So you can have your service description in protobuf and basically design the service with all the endpoints and stuff like that. And a lot of things then get auto-generated in code, which is quite nice. Little thing, let's say little peek also in the future is that we actually want to move away a little bit from gRPC, not the protocol, but the implementation, because the Google gRPC implementation is quite heavy. It includes a lot of different protocols that are not really needed. And there is this quite new project from Buff, which is called Connect RPC, which I think is also now donated to the Linux Foundation, if I'm not mistaken. And it's also quite nice. It also supports gRPC as a protocol. It also has its own protocol, but the implementation of Connect RPC is much more lightweight than Google's gRPC. So we are in the moment thinking about switching to that, but it will still work quite similar to gRPC. Since we are living already in this buff world, because protobuf can also be quite tricky at point, especially if you want to include other protobuf libraries. So we do, as I said, a lot of things with auto generation and dependency management. For that, we use the tool buff, which is also quite good. And you can see on the right here, for example, a definition of just a regular protobuf message that is part of our API. So in this case, it's a cloud service. Cloud service basically represents the cloud service that you're targeting on in a sort of logical way. And you have things like an ID, a name, descriptions, the catalogs that are in scope for that cloud service, timestamps, and so on. And all of them are basically annotated with different libraries or third-party libraries in the protobuf ecosystem. So we are using, for example, buff or proto-validate from buff to annotate these structures with validation rules. So for example, each cloud service must have an ID, otherwise the API call is rejected, which works quite nice. In this case, also must be a UUID. You can even put that in the validation rules. And we are using some other components to insert the struct tags, for example, to our persistence layer, where we use GORM, the object relational mapper, to just persist these things then also in the database. And also works quite nice, and it's a cool tool. And that's also one of the reasons we said, okay, maybe the switch to connect RPC is even more road in this ecosystem. We have to see that we are not completely, let's say, vendor locked in somehow, but it's still our open source project. So we are quite in discussion there. There is a little bit of a caveat. If you want to try that out at the moment in the repository, you will probably only find that usually in the Go project you have the CMD folder with the binaries, and at the moment there is only one engine binary which basically starts all of the service, and you say, oh, this is not really a microservice. Yes. The problem here is that we are working at the moment in splitting this up for the actual binary in the public GitHub repository. We have an older version of Clouditor. We have that in this Medina project. We did already that. We basically need to move that into the GitHub repository, just a small caveat, but you can also just start it with this engine where basically everything is included and you can just try it out. And yes, we need to improve the documentation, so we are aware of that, but this is something we are working on. Okay, now let's go to the next step. So we have this API design, we have all the components. So we want to gather evidences. And how do we do that? And especially, how do we do that in a cloud provider independent way? And also, why are we doing that in a cloud provider independent way? Well, there are, of course, other tools that do that. There are even tools from the cloud providers themselves, like there's like Azure policies, partly Azure Security Defender, Security Center, and stuff like that. We have AWS config rules. But most of them, if not all of them, are very specific to the specific cloud provider technology. And it's a little bit hard if you want to write rules that work basically for all of these different types of cloud services. So I know that you can integrate third party, for example, I think you can integrate your AWS stuff in Azure and so on, but you will still need to deal with specific properties and all of that of the different cloud provider technologies. So you will end up with rules that are specific for the technology, and that doesn't really scale too much, especially if you want to have a lot of rules for a lot of certifications and so on. So what we did is basically coming also from the research world. We said, okay, we need some kind of abstraction layer. And what we did is also, this is also described in the paper if you're interested. We basically built an ontology of different cloud resources, their properties, and also the relation to other resources. And what we can do then is basically we write rules according to the entities of this ontology rather than the technology specific one. So how does that look like? I have a small example here of the ontology. It will fit several DIN A4 papers if you want to print that out. But basically what we have in the bottom is a virtual machine, and the virtual machine, you can see the yellow arrows are basically inheritance. So each virtual machine basically inherits from a generic compute resource because it's compute. And compute itself offers basically inherits it from resource. And these different entities then have different properties or different security features or security properties attached to them. So for example, we said, okay, every compute resource somehow has a network interface because you need to interact with it somehow. Each resource probably has some kind of geolocation because it's deployed somewhere in some cloud region, and so on and so on. And you can basically go through the individual properties and also link them together. So you can say, okay, the virtual machine probably has some kind of boot logging. This boot logging then probably logs to some kind of logging service, and the logging service probably logs to some kind of storage. And storage could be, for example, a block storage, an object storage, whatever. So different kind of things. And this is very powerful because you can basically take all of these properties and write rules for them. And we'll see that in a minute how that works. And because this comes from let's say, a completely another world of semantics and ontologies, and there are certain technologies to deal with that. And if you're familiar with that, this is something like OWL or RDF and stuff like that. And yes, they work quite nice in modeling the semantic stuff, but they don't really work too well in, let's say, the practical world of APIs and RPCs. And there is such a thing, or there are protocols like JSON-LD, but then we would end up with this sort of two worlds, protobuf and JSON-LD, and we didn't really want that. And because we are anyway really into auto-generating things, we basically said, okay, we want to translate these terms into protobuf. So in the end, what you will have is basically you have this ontology on the left side, and we can model all of the properties and so on. But what we want on the API is really at the end just also protobuf messages. So you see on the right side, for example, there's a protobuf message for a virtual machine or a representation of a virtual machine. And this basically includes all of the properties that you can see on the left side in the ontology, and also in a flattened way. So basically it will include the properties of all of the parents. And you can just then fill that in the API in quite a nice way. You even still, with the protobuf options, you get the hierarchy. You can see the resource type names, virtual machine, compute, and so on. So even that is preserved in a way, but it's really just easier to have that, and we don't have any technology break in our API. And then how does it work to translate that? So you can interact with different cloud providers, of course, and then you can map them to the different things in the ontology. So you might have a Kubernetes pod that maps to a container. You might have an Azure VM or an EC2 instance that maps to virtual machine. You might have a Yonos virtual machine that maps to virtual machine, and so on and so on. So this is basically just the way it works. And if we look at how this works in, for example, if you serialize this into JSON, you basically have this representation here of an evidence, has some kind of metadata like an identifier, the time when it was gathered, the service ID, and then just basically more properties that are linked to the ontology. I won't go into details of all of these properties now. This is also not just a complete list, but just to give you an idea of how in the end such a resource is modeled in a generic way. And the cool thing is that because this is a generic way, is that in the end, we can also use that to assess the security properties of these evidences. And we are doing that using Rego. Rego is a, let's say, logic programming language, which is sort of inherited from Catalogue, which is in turn inherited from Prologs, and Prolog is quite old, but and Rego is basically Prolog for JSON, I would say that. So it's also written in Go, which fits well to our ecosystem. And what you can see here is a very, very basic metric, for example, for this metric, which we just call disk encryption enabled for VMs. So it basically checks whether if you have a VM, if all of the block storage that you're attached to basically are encrypted. So you can say, okay, this metric is applicable for a certain type, for example, here a virtual machine, and also only virtual machine which has block storages, because if there are no block storage, then there's no disk encryption. Basically, we need to fetch then some related information about the block storage. Then we can say, okay, this metric is compliant if every disk in this disk set, for example, has at-rest encryption turned on. We could also do more complex things, but we said, okay, we only want to have disk encryption if it's a boot volume and stuff like that, or other properties. But just to give you an example, that we can have these metrics here based on Rego and just evaluate them. And it's still quite readable, I would say, because there are other formats that are not that readable, XML-based and so on. So I think this is quite readable in a way to express such a metric. Just to give you more example, what kind of metrics we have. So for example, we have TLS security, we have logging. There are dozens of metrics. I think we have 30, 40 also in the open source version, more in the non-open source version. So quite a lot of different metrics that we can use. And what we then also did in one of our papers that we published is, okay, we tried to see how can these metrics then fulfill certain requirements or controls in these security catalogs. So for example, we have here the EUCS and the CCM, but you can also do that for the BSI-C5, for example. And just to give you the complete list is much longer, just to give you an idea that, for example, one metric such as transport encryption can, of course, be used to fulfill at least partially different metrics. So for example, for different requirements. So for example, EUCS, you have requirements dealing with operational security and also key management. And of course, for them, you need TLS security. But the other way around is also that these requirements usually involve one then more metrics. So the CKM 02.1 is, I think, something like state-of-the-art TLS security. And for this, of course, you need something like, okay, TLS security exists, it is enforced, it has a suitable Cypher suite, it has a recent version, and probably some other things as well. So it's a sort of a combination of different things. And now, because I think we still have the time, then I will quickly, if everything works, I will quickly show you a demo just to give you an idea. So I just need to go back to Zoom very quick. There is my share button. Stop sharing, and then just quickly share this one. Okay, so basically, so I skipped logging and everything. So basically, once you logged in, you have an overview, and here we have an overview of the different cloud services that we configured. So we have already one here. This is the default one. I just pre-configured it, but you can also, if you want, you can enter new ones. We have sort of a wizard here that guides you through the different steps that you want to do. But for now, we just keep the default one. And you can see here, so it's already some things happening here in the activity log. And basically, one of the first things you want to see is, okay, what kind of resources did we discover in the cloud service? So we have just a very plain overview here of the different services and their types. So there's some object storages here, some block storage, some account. You can already see that, for example, this behind the scenes is probably an Azure storage account, and this is then mapped, for example, to an object storage. And this is an Azure, or what's it called, Azure Web Apps function something, which is then translated into our object of a function, and so on. You can also filter it, search a little bit. So if you have our happy VM here and only want to have the virtual machine, oops, sorry, where is it? Here, then we can select that and so on. You can also go into detail what kind of results there are available for each resource. So we have here, for example, these different results that are according to the different metrics. So we have some of the metrics I showed before, like boot logging, malware protection, and so on. And then you can go into more detail while, for example, certain things failed. For example, here we have somehow the OS logging is enabled, but somehow the retention period is not configured correctly, and so on. So we can go into detail a little bit of things. Won't show that now, but how my things then are failing, for example. And because this list is, yes, it's not really if you readable, and if you have a lot of resources, then it might be a little bit cumbersome. So one of the new features that we added is the resource graph. And the idea behind that is basically to say, okay, you usually, the resource is not just interacting alone, but it's just usually part of a resource group, or is attached to a certain VM and so on, just basically like the relationships in the ontology. And you can see here, it's a little bit more clear already. So you have the cloud account here, we have the resource group in the middle, and basically all of the resources are connected to the resource group. You have the VM here, you have a disk image here, which is not connected to a VM, for example. You have a storage service here and so on. So you can go through the different resources here. You can click on them. You can also see here their security status and so on. And we are also experimenting a little bit with these overlays, so that you can basically say, okay, I want to have sort of an overlay over all of this resource graph to immediately show which kind of resources are read, and I say, okay, here there's VM, there's something wrong here with the boot logging retention. You can click on that and then go back to the assessment result that produced that, and can go more to the details why that failed and so on. And then this is still on the level of the individual assessments, which might be nice also for operations and so on. But for a compliance view, you want to, let's say, aggregate that into a catalog, for example. So you can go into a catalog here. I only have this now, the demo catalog, but let's say, you can also have the IC5 and all of the other different security catalogs here. But just for the demo, I just have the demo catalog here. You can select an assurance level, which will select different controls. Save, and then you have immediately like an overview of the different controls and why if they are okay, if they're not okay, if they are waiting for more data because maybe there is no associated data there, maybe it still is covered and so on. And you can basically also select the different categories here and see, okay, here this is so on, so on, so on. Oops, sorry, refresh here. And also basically drill down again why certain things are failing. So for example, this boot logging category here should log all boot categories. Okay, probably this will fail. Yeah, because our boot logging retention, for example, was not configured correctly. You can also, for example, deal with these gray things where you said, okay, firewall, probably we don't have a check for that, but yeah, okay, it's probably okay. And then you can also say, okay, save that, and it will at least for, let's say, a period of time deal with that in a way that it says, okay, this is probably okay. So if you want to have an audit, you can still say, okay, I didn't have the chance to automatically assess that, but I provided it manually, for example. And you can also basically differentiate between them. So if you can merge all of them, but you can also say, okay, I only want to have this automatic results here, and I have the manual compliance results here, just to differentiate a little bit, to say, okay, I did this one I manually set, and the other ones were actually discovered automatically, for example. Okay, so just to give you a quick idea how it works. Now let me just quickly go back to the slide here. So on future work, we are not finished. So as you see, there's always lots of things to do. We also have some projects where we are doing that. So we want to, for example, expand the resource graph that you just saw. So we want to include more evidences, also more example from the deployment processes or from log files. We also want to actually put the actual application that is usually deployed on such of resources in there. We could reuse certain things, for example, from static code analysis or dependency information. There is also an ongoing research project if we can use AI to scan, for example, policies and procedure documents, where we also have a lot of them usually involved in an audit. We need to probably adjust a little bit our persistence layer if we want to expand the graph. And we have, we need some tweaks and improvements, UI, UX, stuff like that is probably never finished. But before I can close, I also want to say the call to action for you if you're interested. So we are also really looking always for more evidence collectors. So at the moment we have AWS, Azure, Kubernetes, and OpenStack. But if there are specific ones that you're interested in, just please talk to us if you're using any of these technologies. If you said, okay, my API is Kubernetes plus flavor X or so, we can have a look if we can support that somehow, and it's an open source project. You can also support it yourself and so on. So yeah, I just want you to have this call for action. If you're interested, just talk to us. We are always looking for more support in this area and trying to see how we can progress things, put more things in the ontology and stuff like that. But yeah, so that's it from my side. And yeah, I'm of course open to questions or discussions if there is any.
Thank you very much, Christian. Thank you for the very interesting presentation. Are there any questions or comments from the audience? You can just unmute yourself and ask the question, or raise your hand, or even copy or write your question in the chat, and then we will read it out loud. Matthias, you have a question?
Yes. So first of all, thank you for the very interesting talk. Very nice. I have two questions. One is more like an academic one, and the other one is a more practical one. So the practical one first. I really like the user interface, but I'm wondering how this could be integrated into a continuous integration system, something that runs on like, let's say, daily basis or something, that you can generate a report and get an email if something's going wrong. That would be the first question. The second one would be the academic one. I really like the mapping from the ontology to the protobuf. And how do you expect the ontology to be subject to change over time, and how do you deal with that, like versioning the protobuf syntax? Thank you.
Okay, yeah, two very interesting questions. So regarding the CI one, I don't have a definite answer for that, I think. So of course we always have the possibilities to interact with the system using APIs, and of course there are APIs that basically fetch an overall compliance result. You can fetch the individual assessment results and stuff like that. But it's not a flow that we actively thought of, to be honest, yet. So this is a very interesting thing for us. I need to digest that a little bit probably and see how that works. Because the way it currently works is basically that Clouditor itself already does that in a let's say rather stupid continuous way by just doing, for example, checks every 5 minutes. But we had a lot of discussion where we want to move away or let's say complement that with sort of a trigger-based approach where you say, okay, if you have a resource that is not changing, you don't need to fetch the status every 5 minutes because, well, it's not changing. But it would be nice to have sort of a trigger from the outside that says, oh, hey, I just deployed a new version, for example. And then, for example, react on that and then initiate, for example, a reassessment. So this is something that we are very actively exploring, but don't have, let's say, the model how that works yet. But I think this would be a very nice idea because in the end, it's always also a little bit about, let's say, waste of resources because, well, if the status is not changing and you're collecting it every 5 minutes, yeah, okay, you can demonstrate an auditor that I have a perfect log of every 5 minutes, 1 year long, but yeah, what's the point of that? So yeah, so I think it's very, very cool idea to somehow tie that with the CI/CD process and say, okay, hey, I deployed a new version, please check this now, or well, please maybe check it in 5 minutes after everything is settled or something like that. Yeah. So To the second question, yes, this is a very good question, because this is something that we also now experience, because we only recently changed this to this protobuf generation. Before, we had another system which didn't really work, and basically this forced us now to have a new major version in Clouditor. That's why we're working on version 2. And with that in mind, we will probably, before we release version 2, we will need to come up with also a sort of versioning scheme of the ontology itself. So there is some kind of internal versioning in because we were using this tool WebProtégé to build the ontology or to manage it, and this sort of has a Git repository internally. So we have a version control system there, but we don't have a specific version number for the ontology. And the more we think about it and the more discussion we have, we probably need that to say, okay, hey, you are now working with ontology version 2.0, and there will be breaking changes and stuff like that. So we need to also think about that even more now that we're putting into protobuf, and we already encountered some smaller things, like if you add new fields, then you should not change protobuf field numbers and stuff like that. So we probably we already had the idea of basically reading the old protobuf file, sort of having a diff, and then just if you add you remove things or add things that don't touch the existing field numbers, because otherwise things will really explode. But yeah, so this is the way that these practical things will now come into play. Now we have this generation protobuf setup, which is quite recently actually. We just did that, and we are using it internally. The tool we developed internally, so we have that, let's say, in our control to change that. So I hope that answered the question, at least partially.
Yep, sure. Thank you.
Any other questions or comments or points for discussion? And maybe a question from my side, Christian. You showed an example of a catalog at the end.
Mm-hmm, yeah.
But how does this work? So are the catalogs provided by the tool itself, or does every user need to set up their own catalogs? And if a certification criteria changes, for example, how does this work?
Yeah. So the idea is, and we are exploring that at the moment in one of the research projects. There is a standard called OSCAL. I'm not sure if you're aware of that. It's basically an initiative from NIST. It's called it's open source control language. I don't have the exact name, but basically the idea is that this is a standardized format how a security catalog and controls should look like. So, and the idea is basically that we want to support the OSCAL format, and then if somehow the standard is available in OSCAL, you can just import it. And then basically what we still need to do, we need to do the mapping between the controls and the metrics. And for some of the standards, we provide that. But if you, of course, have your own standard, you also need to provide that yourself, basically. So this is one of the things. But we are working also in collaboration with the OSCAL team, if you can somehow put that into the standard and so on. So this is an ongoing sort of research topic also, how to deal with that. But yeah, as I said, so this is a NIST standard. And for example, if you're going into more of the US world, I think FedRAMP, for example, is already available in OSCAL, and there is also some discussion that the new European standards that coming up are also available in the OSCAL format, and you can just then use that and import that, or build your own catalog if you have some internal company compliance regulation framework or something like that.
Okay, thank you very much. Any other questions? Oh, there's a question in the chat, I think. Let me just read it out loud for the rest. Are there specific requirements on the setup of, for example, cloud monitoring tools in the cloud to be monitored before Clouditor will work?
No. So it depends a little on the cloud provider, of course, but for the usual cloud providers, I would say all you need to do is create, depending on what the name is like a service principal or a service user or whatever it's called, with a read-only permission. So we just need read-only permissions. And I think in most of the cloud systems, you either have a role that is called like security reader or security audit. I think it's called in AWS. I think security reader, it's called in Azure. in Kubernetes, there is also like this read all role. So basically you need some kind of machine account that has a read access to the necessary resources. And then basically that's it. Nothing more is required otherwise. Yeah.
Great, thank you.
Okay, sure. Yeah, and if there are any more questions, just, yeah, as I said, my email is here. It's anyway then after that's on YouTube. So just, yeah, feel free to contact us. We are always interested in talking to that. And yes, we are aware we could improve the end user documentation of the project. This is something we are actively working on. Coming from a research field, this is not always was not always our top priority, but it comes more into play the more people now are using it and saying, okay, how do I start that and so on. So we have some quick start with UI examples now also in the README. You can just basically have a one-liner and everything if you have configured your stuff, and you can quickly test it out.
Okay, yeah, so if there are any other questions, then you can just contact Christian afterwards, and remember also his call to action.
Yes.
Okay, thank you very much, Christian. So I will share my screen again right now because we have a couple of events to share, as I mentioned. Okay, so as I mentioned at the beginning, we have some events and news that we would like to share. But if you have anything that you want to share with the rest and you have not let us know yet, then please feel free to do so afterwards. So first, I would like to ask Felix from Sovereign Cloud Stack to present the Sovereign Cloud Stack Summit whenever you're ready, Felix.
Yes, hi, and thanks again for the nice talk. It was really interesting. Yes, since the STS project develops the STS standards together with ALASCA, we thought it would be very fitting to also come to the ALASCA Tech Talk and invite everyone here to the STS Summit that will happen in May this year, on the 14th of May in Berlin. And it's the second STS Summit. So last year we had our first and had 2 half days in Berlin that were really interesting, and where we presented the state of SCS as it was last year. And of course, this year we'll do the same. The format is changed a bit. Instead of 2 half days, we are going to have 1 full day. That was due to the feedback that we got. And we'll start in the morning at 9 a.m. And we'll have a day of panel discussions, talks, and examples from people that adopted SCS, either the reference implementation or the standards. And we will close that up with a social, I think it's called social networking in the evening. It's basically a nice evening event, and where you can meet new people and meet old friends. And actually, that's not the only reason to come to Berlin, because on the day afterwards, there's the Open Infra Day Germany, because this year the Open Infra Foundation has decided, instead of doing one large summit, to do various regional events. And the one in Germany is organized together with the SCS Summit. So on the day afterwards, on the 15th of May, the Open Infra Day Germany is going to happen. And they can also expect a lot of people from the OpenStack community to show up, and we will have talks there as well. And so with these 2 events, there's actually quite a reason to come to Berlin. And if you've not had enough, there's probably going to be a meetup of the Public Cloud Special Interest Group of Open Infra the day after the Open Infra Day Germany, so on the 16th. So there's not a slide for that, but Tobias Rudberg and me, we are both chairing the Public Cloud SIG at Open Infra. We decided that if people come for the Open Infra Day Germany, we might as well see that we are going to get a few people from the public cloud space together there as well, and do that. So plan your May, and it's embedded in between 2 public holiday weekends. So perfect to have family, then lots of cool stuff in Berlin, and then family again. And thanks, Maria, that I had the chance to pitch these here and invite all of you. And with that, I would hand back to you, Maria.
Thank you very much, Felix. It really looks like Berlin is the place to be in mid-May. Okay, so we have also another event that we would like to share with you. So my colleague Sarah, who's mainly organizing this event, will say some words on this. So Sarah, whenever you're ready.
Yes, hello. Sorry, I have some problems with my video camera, but you can fortunately hear my voice. Is it okay? Can you hear me?
Yes, we can hear you.
So hi everyone. Thanks Maria. Also from my side, thanks to very interesting talk, Christian. So for those who don't know me, I'm Sarah. I'm part of the marketing team of ALASCA, and we are very excited to announce that the first ALASCA Summit with the theme Beyond Boundaries, Shaping Europe's Digital Future Together will take place this year in October 29th and 30th in Dresden. The summit offers a great opportunity to explore ALASCA's open source projects and connect with the community driving these projects. So there will also be a platform to showcase additional open source tools and technologies. So we are currently finalizing the program and invite you to contribute presentations, workshops, or any other ideas until the end of April. And additionally, sponsorship opportunities are available. So for more information, please visit the summit page on alaska.cloud. So you can find also the link here. And there you will find all updates on the event and details on how you can contribute. You can also subscribe to our mailing list to receive all information by email. So if you have any questions, please feel free to contact us. So we look forward to seeing you at the summit in Dresden and engaging with you in person. So I'm sorry that you can't see my face now, but you will see it maybe next time or in Dresden later. So sorry for that.
Or at least in a picture if you visit the website.
Yeah.
Okay, thank you very much, Sarah. Okay, so if there's anyone else who wants to share any news or any events with the rest, then please feel free to do so. Otherwise, I have a short overview of the upcoming Tech Talks for the next month. So in March, there's an exception in March. It's not going to be the last Friday of March because it's a holiday in many countries. It's going to be the Friday before that, so it's the 22nd of March. We have a presentation by Politecnico di Milano with the title "A DevOps Approach for AI Applications at the Edge," based on the European project AI Sprint, which just ended last year. Then on the 26th of April, we have Dresden Internet Exchange presentation. They will talk about how a local infrastructure can have a local impact. And then on the 31st of May, we have a presentation by the Universidad Politécnica de Valencia. They will present an open source tool called Infrastructure Manager. So that's what's coming up. And I see that Sarah has her camera on now. So now you can see her. Okay. So if there are no other comments or points to share, then please stay tuned to our website and our social media to find out more about the next Tech Talks and the news from the association. You can also watch past Tech Talks on YouTube, which we always upload after a couple of weeks after the talk. And otherwise, we can meet here again in a few weeks, actually in a month, more or less exactly, 4 weeks. On the 22nd of March for the next Tech Talk by Politecnico di Milano. So thank you everyone for joining. Thank you especially to Christian for the Tech Talk and also for everyone who joined the discussion and who shared their news with the community, and just for being here and listening. We hope that you enjoyed it very much. So see you soon, and yeah, have a nice weekend.
Thank you. Bye.
Bye.